Welcome. In this short video, I intend to show how we can use Magnet Office to create cross-sections through a DTM and then show those cross-sections as a nested drawing within the main drawing. So on the screen you will see a DTM mesh in green of a original ground surface or original OGL, and the red DTM relates to a flat plane at elevation 100 meters. I can give you a clearer example if I actually show the plot in 3D. It's a 3D view. So I'm right clicking in 3D and then asking you to show both surfaces. And on the screen, hopefully you can see the green surface and below the flat plane, the secondary surface. It's actually clearer if you make the vertical exaggeration bigger on the display. So settings, vertical exaggeration, normally set to 1, change that to 5, and you will see exactly what we're talking about. So the green is the OGL, and I've created a flat design plane, I'm calling it, at 100 meter elevation. Okay, so first of all, to create the cross sections, we need to create an alignment, a horizontal alignment. So that's design, create alignment, and again the alignment can take any path through the DTM. The colors don't show great here at the moment, but I'm dragging a line through the DTM. Right click and insert alignment, and it's giving me the details, calling it align to. I'm putting on layer alignment. Okay, now created by alignment, we now need to produce cross sections. So we can use the command design cross sections from DTM. So the alignment name is in the box. We can change the surface name if we wish to something more relevant, which is OGL, and we can choose the DTM that we want to draw that alignment through. In this case, we're going to draw it through the original ground level DTM. Left and right offsets, in other words 50 meters to the left and 50 meters to the right of the alignment, and spacing, how often do we want, what interval do we want between the cross sections along the alignment, so 50 meters. Click OK. We come up with an additional chainage if we want to increase or reduce the amount of cross sections between specific chainages, which we don't in this case, so OK on that. And it's not easy to see again on the screen, but the cross sections have been drawn. You can see cross sections drawn 90 degrees to the alignment. So to view those cross sections, I'm going to go into the roads view. I'm going to select this icon here, and then select the alignment that we're using. And this now takes us into the roads view of Magnet Office. So here we have a plan view of the survey with the alignment shown there, a cross section here, and this is a long section. So this cross section shown in the right hand pane relates to this location here, and we can use as a play arrow here to actually show us what happens as we move through the cross sections, and you can see the corresponding shape of the terrain changing as we move along the alignment. So the next thing is to actually plot these cross sections. So we're going to plotting, and we'll go plot cross section. Okay, so this is showing the cross sections on the sheet. It's not very clear at the moment, but we can always go into the settings for the plotting. So cross section plot settings. That's accessed by going settings and cross section settings. Here we have the title box that's chosen and the scales, horizontal and vertical scale. In the cross section table tab, I'm going to select the format as urban, which will change the layout slightly. I'm going to put text on all the sheets. There might be some text I want to put before the chainage specification or the chainage selection, so text before, I might write chainage in here. The tab surface plot settings asks me what surfaces I need to show. At the moment I'm just showing the OGL, and I will show the second cross section there. Click OK on that one. So that's a basic cross section, chainage shown there, and the levels shown along the cross section, like so. So that's a simple cross section, but what I'd like to do is show these cross sections in relation to the design model. So I'm going to go back to my original survey. That's the survey, just as a refresh, and we're actually now going to use the same alignment but draw it through the different surface, and we're going to give it a special name. We're going to call it the design surface. So design, cross sections from DTM. This time we're going to use type in the name design, which has a special significance within the software, which you'll see in a minute. I'm going to choose the DTM as a plane at 100 meters. Leave the offsets the same values, and the spacing, chainage spacing, the same values. OK on this dialog. And then there's the warning that the design name is reserved for a design surface, and asking me to confirm that I want to proceed with this. So I will do. We don't want additional chainages. So again, the cross sections have been drawn, but this time they're drawn through the design surface. Again, if I go back to my roads view, now you'll see that we have two surfaces, the red surface being the design and the green surface, the OGL, both in the cross-section pane and the long section pane here. So again, if I play the sequence, that will then show you at various chainages the differences between the design surface, the red surface at 100 meters, and the original ground level surface. So we've got two surfaces. So let's now have a look at the plot, the drawing that we created. And now we can go into the cross-section settings and the surface plot settings, and turn on the second surface, which is the design surface in red. And that should then, we also need to go into cross-section settings and check this box here, which is level difference. In other words, what's the level difference from the design to the DTM shown here, in this case the OGL. So we'll click OK, and you'll see again straight away that it has now changed the series of cross sections to show the relevance between the OGL. In this example here, the OGL is 101.07, the design is 100, and the difference from design to OGL is 1.07 meters. Again, very simple example, and we can increase the number of levels shown on the section if we so wish, but for the moment that's good enough. Okay, so what we've got now then is the cross-section drawing. I'm going to go back into the main survey to create a plan of the survey. So here we are, and I'm going to use the command which is File, Create Plot Window. I'm going to choose a large sheet, A1 sheet. I'm going to pull that over the survey and make sure there's plenty of room for the next exercise that I'm going to do, which is to show how we would inset a subdrawing. I'm going to make the scale 1 to 2000. Okay, and I click OK. So we've now got if we look at the tabs at the bottom, we've got a drawing, a plan of the site, which is drawing 10 in this instance. We've also got a drawing of the cross sections, which is drawing 09. So what I'd like to do is bring this drawing into which is this cross-section drawing, into the main plan drawing. And to do that, I'm going to use the command insert subdrawing. Sorry, I do apologize. I'm going to use the command which is view and viewports. Create a new viewport and call it section, let's say. Okay, and what it's asking me to now is define this viewport. So I'm going to left click and drag around the cross section box, and then left click, and that viewport has been created. So this is created in drawing 09. I'm now going to flip to my plan drawing, which is drawing 10. And I'm going to bring those sections in. So I'm going to use the command insert subdrawing. And you'll see under drawing 9, I've created the viewport section. I'm going to OK to that, which brings in the section. And we're going to fix that in this drawing. Now, obviously, it's been brought in true to scale. And if we want something indicative, or normally we would have played around with this to create the right display. But what I'm doing now is just reducing the scale of the cross sections, just so that they can be nested in the main drawing. So finally, there is an option in this viewport. If we double click on it, you can then show the border or not show the border, make it opaque, and change the scale or note the scale of the inserted window. So that's one important thing to note, that the scale of the inserted window may not be true to scale, but we just need to bear that in mind when we're showing it next to the main drawing, so that the customer is aware that the scale of the inserted drawing may not be 1-to-1 or might differ from the main drawing scale. And that completes this short video on how to create cross sections and how to bring a subdrawing into a master plan.